Hello, everybody. My name is Alex. I'm here to present Hulk, Eliciting Malicious behavior for browser extensions. This is a joint work with Grier and Vern Paxson from UC Berkeley and in the National Computer Science Institute, Neha Chachra from UC San Diego, and Kruegel and Giovanni Vigna, my advisors from UC Santa Barbara. Obviously, you have guessed that this work is about browser extensions. A browser extension is a small program of HTML and JavaScript that runs inside the browser. And its goal is to modify and enhance the functionality of the browser. This is done differently than the traditional JavaScript that we have in the browser because it has access to a privileged API provided by the browser so that it can do more stuff than the web applications that you visit while you browse the web. And it's supported by all major browsers. One of the most popular extensions is AdBlock Plus. AdBlock has more than 50 million active users across all browsers. And its goal is basically to remove advertisements from your visited pages. What it does is that it looks for iframes, and it has a whitelist or a blacklist. And whenever it encounters an iframe that is in its blacklist, it will remove that iframe from your site. Of course, there are more problematic cases, like this add-on over here, the Facebook color changer, which functionality is to change the color on your Facebook page. And this has actually, this is very small, but it has actually 330,000 installations. This is active users that have this extension installed. And it's not malicious per se, but it does have access to all of your websites. So when you go to, with an update, this extension could potentially become very malicious because it does have access to all your data from the website that you visit and all your browsing history. Traditionally, to compromise the browser so far, we had drive-by downloads. These are attacks against the browser or its plugins that try to exploit the vulnerabilities that exist there and install malware into your system. But now, we have also browser extensions that are programs that are already running into your system. So let's see how this compares to malware. The browser is basically controlling your local resources, and the web application asks for the browser to do stuff with the local resources. And when you get a drive-by download, you basically manage to install malware that runs at the same level as the browser and has access to the same resources. But what differs with the extension is that it's a little bit in the middle. It has access to some of the resources of the browser, but not entirely the same privileges as the browser does. So can we actually have extensions that are malicious in this context? And the answer is yes, because we can do a lot of stuff from inside the browser. We can inject advertisements. We can do keyloggers that basically intercept the keystrokes that are directed to a visited page. We can do affiliate fraud that I'm going to explain in a little bit. And we can steal credentials. The truth is that we have JavaScript running in the browser from the extension. And whatever we can do with JavaScript in the context of a page, we can do it maliciously. The goal of this paper was to understand malicious behavior in browser extensions in general and identify automatically these malicious browser extensions. And for this, we built Hulk, a system that we automatically analyze extensions and identify the malicious ones. The approach that we took was to install extensions inside a virtual machine that runs Chrome, visit a few pages, monitor what the extension is doing, and classify the extension. There are several challenges into analyzing browser extension. And the most obvious one is that we don't have all the pieces of the puzzle. A browser extension is supposed to operate on a website. We do have the code of the extension, but we're missing the web pages that we should visit to trigger the behavior. So one of the challenges is how can we trigger malicious code in the browser extension? We need to find, first of all, the content that the page should contain that triggers that code. Think, for example, AdBlock. If you visit a page that contains an advertisement, then AdBlock will do something with that. Otherwise, it doesn't matter what URL you're visiting, as long as there is an advertisement inside that page that you visit. In the same sense, we need to figure out which actual pages to visit, because some of the extensions will trigger not on the content, but on the page that you visit. Like the Facebook color change, you just need to visit Facebook. It doesn't really matter the content that you're going to face there. It's going to trigger only on facebook.com. And a general problem is that how can we detect maliciousness? Even if we trigger the malicious code, how can we realize that that what executed was actually malicious? And with Hulk, we have several techniques, novel techniques that can trigger malicious behavior. First of all, to find the right content, we are introducing the notion of HoneyPage, and I'm going to explain in a little bit what a HoneyPage is. Then, to visit the right page, we do URL extraction from the source code. So we look into the source code of the extension. If we find any URLs, we're going to visit them. And lastly, we do event handler fuzzing, and I'm going to explain that immediately after HoneyPages. So what is a HoneyPage? A HoneyPage is a specially crafted page that is basically empty. It doesn't have any content. But it has special JavaScript in it that overrides some of the JavaScript functions that are being used from the extensions to query elements in the DOM tree of the visited page. So for example, if the extension is trying to find an element in your DOM tree that is your Facebook newsfeed, what is happening in a HoneyPage is that it intercepts this query, creates the element on the fly, and then returns to the extension the newly created element. From the perspective of the extension, it doesn't know that this element didn't exist in the first place. It just gets, it asks for something, and it gets it back. Complementary to HoneyPages, we have event handler fuzzing. Extensions can ask permission to intercept network events in the browser. But we found a way so that we can trigger these event handlers programmatically. What this means is that we can pretend that we're visiting the Alexa top 1 million domains, point to a HoneyPage so that if the extension is about to operate on an element that doesn't exist because we're not actually visiting the pages, then the HoneyPage will automatically create it for the extension. And this is a process that takes on average less than 10 seconds. And now there's no network request that is happening right now. It's just we're exercising the event handler for the web request. So how can we detect malicious behavior in this context? We look into JavaScript, and we monitor how the extensions are using the special API provided by the browser. And we also look at how the extension is interacting with the visited pages. We also look at the network, and I'm going to explain a little bit why we'll look at the network level to find maliciousness. And we also look at the injected code that is being injected into the websites that the user is visiting. With all of this, we developed malicious behavior heuristics to detect maliciousness. We found cases online that extension will prevent the user from uninstalling the extension. And this is possible because the extension will basically monitor if you're opening a tab with the extension settings and close it. And then there's no other way in the Chrome browser to actually remove the extension. So we found cases like this. We found also cases that the extension will look for email and password forms in the pages that you visit and access the content. We also found cases where it will register a callback for every keystroke that you make inside the website. Another case that we found is extensions that manipulate security-related HTTP headers. So they will remove CSP headers so that they can inject their code into the page, although the page security policy was different in the beginning. And then we found extensions that will uninstall other extensions. We decided to also have some more relaxed heuristics for cases that we couldn't characterize immediately, and we consider them suspicious. These are extensions that will do, for example, injection of dynamic JavaScript. This is not malicious per se, but it means that the code that we have by downloading the extension is not there, and they're fetching additional code to be executed later, which can change at any time. We also found cases that the extensions will do evals inside the extension, which means that probably we're using obfuscation techniques and they were generating locally more code. A few of the cases that we were monitoring for the network logs are cases where we found HTTP errors and are trying to contact non-existent domains. And in these scenarios, it was basically cases where the extension will try to load more code, but for some reason, the server wouldn't have the JavaScript anymore there, and it will return an error. So we went to the web store, and we caught as many extensions as we could at the time. And we also used, that was 48,000 extensions. And we also used Anubis, which is a binary analysis system that we have in Santa Barbara, to get extensions from there. And what we found in Anubis is that there were binaries that will drop to the file system extensions. This is a process that is called side-loading extensions. And Google has blocked this in Windows because it was being abused by malware. So we scanned all of these with Hulk. And we detected 4,700 suspicious cases and 130 malicious cases. And as you can see, the extensions that we got from Anubis were not all malicious, and they were mostly falling in the case that they were doing network requests to fetch additional code, and they were failing. So we couldn't see that they were malicious or what they were doing in the past, but we could see that they were doing something suspicious to the very least. So we have a few cases that we found as malicious. This is called, it was an extension that it was called Similar Sites Pro. And this extension was installed in 1.8 million users. And what it was, the functionality of the extension is to provide similar sites. So you go to Amazon.com, you click on the extension, and you get a list of similar shopping sites, like Newegg or Walmart or whatever. But on the side, the extension was also looking into every page that you visit, and if it found iframes of specific size, which there were obviously ad banners, it will actually swap them and put its own advertisements there. And if you notice, these advertisements are actually trying to convince the user to download something, to download more malware, which is really, really scary. Another extension that we found is split screen. This was installed into 53,000 users, and what it was actually doing is it was splitting the screen. And this is actually, it compromises the user security so much that it's very problematic. If you can notice, the URL over here is actually a local Chrome URL pointing to the extension, so you don't actually see the actual URL that you're visiting. And these two elements here, they're just forms, and both of them are pointing to the wrong URL in this case, because kapravelos.com should redirect you to my edu website, and this is a Google search that I clicked then to get to the review. So this is you don't know actually the URLs that I'm seeing here. And what's the problem with this extension is that this is a review of a camera, and what happens here is that this is a blog review, and if you click on this link that points to the Amazon product, and the customer buys that, then Amazon will give some money back to the blogger, and this is an affiliate program. And what happens is that this extension specifically, it will change the ID of the affiliate program, and the money will not go back to the blogger, they will go back to the extension author. So they're hijacking the money that the review is producing, basically. Of course, we have some recommendations to improve the Chrome browser extension ecosystem. We believe that we should reduce the functionality that we provide to the extension authors by, for example, manipulating configuration pages. This should not be possible to close the tab that has your extension configuration open. You should not be able to uninstall other extensions. You should not be able to remove security-related HTTP headers because you're compromising the security policy of the website that you're visiting. And we believe that it's way too powerful to have to register for keyboard events and hijack basically all the keystrokes that go to the website. Another thing that we propose is that it should not be able for the extension to have dynamically fetching more code in the context of the extension and execute it, because this makes basically static analysis impossible, and it also can be the case that we cannot analyze dynamically the code. And Chrome actually offers a very good update system so that you can push a new version of the extension to all of your installations. So we should remove the functionality of being able to generate dynamic code in the context of the extension. Of course, our system has limitations. It's a dynamic analysis system after all. If we don't execute, the code that is malicious, then we will never be able to say that it's actually malicious. We can have targeted attacks against the browser, like you need to run this extension from a specific country or in a specific time frame. Against HoneyPages, we can have multi-step queries in the DOM. So for example, asking for a specific DOM element and then for an attribute is not supported right now from HoneyPages. And of course, we can have evasions against HoneyPages, where you can ask for a random div element and it will be there. So you can know that it is running under a HoneyPage. So in conclusion, we presented Hulk, a dynamic analysis system for browser extensions. We managed to detect malicious extensions affecting millions of users, and we proposed changes in the Chrome browser ecosystem that will improve the browser extensions. So with that, I would like to thank you.
Thank the speaker.
Sebastian Zemek of Columbia University. Do you have any results about false positives or negatives? Or, for example, connecting to the jQuery library is harmless. Did you detect anything like that?
So we, of course, couldn't process. I couldn't analyze 4,000 samples, 5,000 samples by manually. But we do know that, for example, we will see the malicious behavior, like they will hook the keyboard events, but they will not send them to a third party. They will just trying to register shortcuts for extensions to have keyboard shortcuts in extensions. So this, I understand that this is not malicious, but they were abusing completely the functionality that is offered from the browser extensions. And yes, we didn't look into them.
Nicholas Christen, Carnegie Mellon. One thing that struck me during the presentation is that this horrible split screen extension had a rating of 4 stars with about 331 people contributing to the reviews. And I was wondering if you took a look actually at these reviews to see, for instance, evidence of adversarial reviews, because I cannot believe that something that nasty gets so many positive reviews. So I'm willing to bet that somebody is actually planting those to actually rise the rankings, and that could actually give you some more information about the campaigns.
So the extension has 330,000 installations. It actually has like 4,600 reviews, if I remember correctly. And I look at the code actually, and I didn't find anything that is malicious there. So it does what it advertises. It changes the color. Yeah.
Thank you.
Bimal Vishwanath, MPISWS. So very interesting work. So my question is sort of in the future work direction. I noticed that one of the, like you just mentioned that one of the extensions had lots of downloads or installs, right? So is it possible to automatically identify these infected users? In other words, some of the extensions, one example you showed was the case of Facebook color changer. Some of these activity traces left by the malware or this extension could be, is most likely going to be public. So is it possible to, as a next step, to identify these users and maybe notify them and to take steps and so on?
So we have reported to Google all the findings of Hulk, and they have pulled from the Chrome store many of the extensions. So these extensions, if you pull them from the web store, it gets automatically uninstalled into all the browsers. So I think this is the path to go.
Okay, thank you.
So Yossi from Columbia. Thank you for the very interesting talk, Alex.
Thank you.
There was a news report a few months ago about a plugin author, I think it was a Firefox plugin, who sold his code and his installation to a malicious party, who then did, I think, search replacements and homepage takeovers and so on. So in your results, do you see any evidence that previous versions of these extensions were benign and then they became malicious, or were they like bad all the way?
So we didn't look at the evolution of extensions over time, but it's a real problem because apparently if you create an extension and it becomes popular, there is a price for that because you basically are buying installations.
Yes.
And we're talking about hundreds of thousands or millions of installations. So in the black market, there's a price for that and you can buy. And if you actually look on Reddit, there are many extension authors that say that they were approached by people to buy, either to buy the extension or to add a line of JavaScript into their extension.
Okay. So, but you don't have evidence for this in
I didn't look
malicious
into the
extension.
evolution. We took a snapshot and we scanned everything.
Okay, so thank you.
Thank you very much.
All right.